All right, let's get this party started. So welcome everybody to quickly test and scale enterprise apps with event-driven architecture. Thank you so much for taking time out of your evening or morning or afternoon, wherever you find yourself in the world, and whenever you're watching this. Thank you so much for tuning in. My name is Jacob Smith. I'm not sure if that shows up on everybody's screens. I'm joined by my right hand, Ryan Robinson. Wave to the people, Ryan. And I'm the community director for Collider Detroit. We're your hosts for this evening. So quickly, just some quick points about Collider, and then we'll dive into the session. Collider is a community for technology leaders to connect and explore innovative solutions. So we're constantly looking for different types of technologies and techniques and methodologies that can help you be better at your job effectively, and connect you to other people who can help you take things to the next level. So if that sounds of interest, we strongly encourage you to keep in touch and to join our various channels so that we can keep this conversation going beyond today. Particularly, we have an active Slack channel with a DevOps and cloud computing channel that we'd love you to tune in for. So I'm going to drop a link to that for anyone who is interested in continuing the conversation beyond today. One more quick plug about us, highly relevant for this group. We have another session actually next week, next Tuesday, about migrating cloud platforms, also with a focus kind of on scalability and what considerations to make when thinking about switching from one cloud platform to another. So be sure to tune in for that. Rye, if you wouldn't mind dropping the link for that in the chat, that would be helpful. Thank you. And without further ado, I'd love to dive into today's session. So again, we're talking about event-driven architecture and how it can be used to quickly test and scale enterprise applications. Please note that the intention for these talks is to be highly interactive. So please, we've got a lot of really smart people in the room. Many of you, I'm assuming, have experience to varying degrees with event-driven architecture and related technologies. So please feel free to chime in. The chat is probably the easiest during the presentation. We'll also open it up at the end, but please feel free to chime in throughout the talk here with insights, with questions, anything that you that feels right in the moment. Please feel free to chime in. I also want to note that the session is being recorded. So if you want to be able to reference anything later or share it with a friend or anything like that, we'll be following up with the YouTube link within the next few days here. So again, thank you so much for joining. Now to break off today's conversation, I do not know a ton about event-driven architecture. I've been learning as I've prepared for this session, but that's why I brought in my really smart colleagues, Shiva and David. So Shiva and David are both senior software engineers with extensive experience. They're our subject matter experts for the evening. They actively work with event-driven architecture and have a lot of valuable perspective to share. So I'm very excited to bring that knowledge to this group. And without further ado, I'm going to hand it off, I believe, to Shiva to kick off today's conversation.
Thank you very much, Jacob. Hi, everyone. My name is Shiva. First, I would like to request David to share his screen so we can, first start with our PowerPoint presentation. Thank you very much. Okay, so today we'll be talking about this event-driven architecture. And, when we are designing system in an event-driven way, we usually have those 4 patterns in mind, right? So depending on what problem you're trying to solve, those patterns may or may not be applied. So we are going to, discuss a little bit about those patterns, talk about the pro and the cons, and then at the second part of the presentation, David will go into a little bit more details and explain the flow of synchronous and non-synchronous, basically blocking and unblocking systems. So to start, maybe, David, can you please go to the second slide? Thank you. So we will be starting with event notifications, and then we will be talking about event carry state transfer, event sourcing, and we will be ending with our CTRS pattern. Next slide, please. Okay, so the first pattern that we're going to discuss today is about event notification pattern. Now, the first question would be, what is event notification pattern, right? But I feel it's always making more sense if we first, define a given scenario, and then we try to apply this pattern on top of it. So it will be basically a little bit easier to understand what we're trying to discuss. So let's do that first. Let's imagine a given scenario where we get a task to build a global scoring application, right? So this global scoring application will be used by, we can say, different government institutions. And what this scoring application's responsibility should be is that it should keep track of, every citizen's driving history, criminal activity, or we can say history as well. And we also know beforehand that this scoring application will be reporting the data to other, other companies or maybe banks or private, institutions as well as insurance companies, right? So that is something we know before implementing this kind of application. Okay, now suppose that we have this application in production, right? And we also now take a real case scenario where maybe there is someone out there that went out driving and met, for instance, with an accident, right? And let's say we implement our design in a way that every event or every action that occurs, like something like an accident or something like someone committed a crime, right? So those are considered as to be violations, right? So in this case, someone met with an accident, we are defining it as to be a violation. And every time such a violation occurs, this scoring application will be triggered. That is how we are designing the implementation right now. And how it will be triggered, that is something we probably don't need to worry about right now. It might be maybe, let's say, an accident that took place, right? And then let's say maybe the police officers probably will be triggering the system, or maybe the institution that creates those crash reports probably will be triggering the system. So for now, we don't really need to care about that. We just have to understand that this system will get triggered, right? Now, since this applications has integration with the banking, private, and insurance companies, it would not be an ideal situation for the scoring application to pass out this information to all the companies, right? Because we don't know how many companies will be using this data and how many, I will be referring companies as consumers now because they are consuming this data. So, I'll be talking in terms of consumers. And the global application, which is the application we're trying to build, we will be referring it as to be a producer, right? Because it is producing those events and publishing it to a particular centralized, location, which we can also refer as an event queue for now. So another way to look at this problem is, instead of us calling out those companies and those listeners or those consumers, we can maybe just create an event, right? An event out of this case and send it out. And when we talk about an event, you can, in computer science, you can just think about an event as to be an object for now, okay? So we create an object and we push it to, a centralized location, which can be an event queue, right? Just a place where all the events are getting passed into. So what happens now is that every time this scoring application updates an entity, which probably represents a citizen in our case, right? Because we're trying to keep track of our citizens, behavior. It emits an event to that queue, which can be consumed by any of those companies, right? That is how we are designing the implementation right now. So when this particular event reaches them, the listeners, the consumers, they can decide whether or not they need to trigger any flow from their side based on their business needs, right? So this is the whole point of this pattern, which is an event as a notification. We are doing nothing than using events as a notification to other parties, right? So let the consumer depend on the queue in the case, rather than the producer sending out the notifications individually to them, because that is what we call nowadays as a reversal dependency, right? We don't really depend on them, or in terms of having their endpoint or having their location to submit data towards them in order for them to process it further. So we create this mechanism where we create events out of those accidents and criminal activities, and when we push it to the centralized location, which is called an event queue. Now, in this way, you have less dependencies from your side, right? In terms of the producer side to the consumer. because if something changes over the remote side, let's say something changes in the banking application or something changes over the private institution, right? We don't need to worry as to be a producer because we don't care about that. We have only one responsibility, which is creating an event and pushing it to an event queue. The rest is up to the consumer whether or not they want to consume it, and if they consume it, whether or not they want to perform any activity on that. Well, there is, I already mentioned it, but I want to maybe put a little bit more focus on it, which is a pro of this pattern, right? That producer doesn't even know who is connected to the queue. I mean, you are the one designing and implementing the system, so you have the data that whoever is listening to your queue, but you don't need to care about that because you have only one responsibility and you want to make sure you fulfill that. So this way you can easily connect other customers to your system without making any change over the producer side, right? And which is, I think, very powerful because that is what, brings a lot of great decouplings, right? You have less dependencies, so you don't need to maintain a lot of, integrations with, different parts of your system. Well, in an event notification system, the idea is to create events of things that got changed or things that occur, right? That's how we define an event. But an example would, a more concrete example would be that, let's say the system could emit an event that states the score for a particular citizen that got changed, right? Or another scenario would be the system could emit let's say an event that states that some data of a particular citizen got changed. We don't know yet, but something got changed. So that is called an event. So maybe the citizen is not a citizen anymore, probably because he changed his nationality, right? But the event only consisted of an event that represented an update for the citizen, right? So it's up to you what you want to put into that event object as to be a notification for your clients or your consumers, right? One way is just to mention that, hey, there is an update and the rest is up to the clients whether they want to do something with that information. Maybe a private company needs to know that, hey, I have an employee and I've just got an update from this global scoring application that states that, this citizen is not a citizen anymore. So this company in particular needs to do something with that data, right? So one way to do that, and probably the only way to figure out is, what got changed, is that the consumer needs to make a callback to the producer asking or requesting for that particular data. Hey, like you mentioned that something for this citizen with ID 1 got changed, but I need to know what actually got changed, right? And even if you provide that, hey, this citizen with ID is a non-citizen at this point in time, maybe still the employee or the private company needs to know that what actually got changed, that he went from a citizen to a non-citizen. Maybe they need additional payload. Maybe they need data like what is his new nationality or where is he at the moment, when did he last visited the country, right? So additional data, probably it's what they are going to request our server or our producer to get that in order to perform their activity. So here you can see that event notification systems mostly requires additional calls from consumers to the producer requesting for additional data if needed, right? Now, we could reduce this load by adding more information into that event, or maybe add as much as possible data into that event object so that the producer does not even need to make additional calls to the consumer. So that's one way to fix the problem, right? And also the problem here is that the producer will get a lot of traffic from different kind of consumers where they are just requesting data associated with an event, that got consumed by the clients, right? And we don't know beforehand how many consumer we will have in the future. It might be maybe thousands, it might be even millions, you don't even know, right? And again, you could also solve the problem by adding more, you can maybe scale up your producers, but probably that's not the best way of doing it when you're using event as a notification. But the pattern, or basically the flow that I just explained by adding additional payload into the event, is the second pattern that I actually wanted to discuss about, which is now event carried state transfer. So if you look into the diagram that's being displayed into this slide here, this is exactly what I'm trying to explain, right? We have an event queue where all those events are getting pushed to. In this diagram, we have 3 services that are pushing data. But in our example, we just have one global application that pushes notifications to a queue. And we have a lot of companies, which are again, services that are consuming this data. Now, in this pattern, which is the event carry state transfer pattern, we implement our flow in a way that the consumer won't be calling the producers anymore requesting for data, right? Because they already have the data at the time of consuming the event. That is the whole idea of having an event carry state transfer. So instead of just mentioning that something got changed, we are not doing that alone, but we are also mentioning this is what got changed, and this is the whole object, which is probably the new object, which represent the new state, right, of the application. So the problem this pattern solves is that no consumer ever need to call back the producer requesting data, because all they will ever need is already there in the event object. And also this gives us really, really great benefits, right? Some of those benefits are you will be improving your performance because we don't need to have additional calls from the consumer to the producer requesting for more data. They already have everything they need. The second thing is most probably the availability, right? Since we are sending the payload along the way when the event is being emitted, this data is now also part of the service that's consuming this event. Because when they get the event, they parse it, they get the payload, they can persist it, and they can perform their own operation on top of that. And because of that, we are gaining a high availability, right? Because let's say our global application system is down for a reason, right? We don't know, we don't care about that right now, but assume that it goes down, and the same scenario, the employer needs to know what got changed of the employee, right? And they are making a call to our system or to the producer system, and because of the producer system is down, they are not able to access the data, which they really need the data at the time of getting the event. So this gives us high availability as well. Together with that, we get more decoupling because now we even have less dependency between the producers to the consumer as well. And one of the major benefits, which we already discussed about, which was the reducing the load on the producer side, because we will not be expecting any calls from any client. They already have all the data. Now, the only con I think at this time for this pattern is that getting a high availability talks for itself that you will be getting a problem with consistency, right? So eventual consistency might be a problem because you will be having the same data at different places, at different microservices, or in this case, companies will be having the same data at different places. But the problem is that it might be out of sync, right? As I mentioned, that if something goes wrong, and if, let's say, if a new event comes in and the state gets updated in our producer side, and some data operations is going on in the client side, they will be using their local data because they're not calling us anymore because we're using event carry state transfer, then we would be end up getting, eventual consistency problem. But again, that depends on whether you can afford that in your project, right? If you can afford that eventual consistency problem, then why not having this event carry state transfer, because it gives you all those benefits of availability and high performance and all those kind of things. Okay. The next one, go to the next one. Yes.
Just to pause quickly, I'm just curious, lots of amazing information. Curious if anybody has any questions, just with a friendly reminder to drop questions in the chat. Lots of information being shared, so feel free to chime in if anything comes up.
Perfect. Thank you very much.
Thanks, Shiva.
Okay, and so the next one, which is I believe the most famous pattern, is event sourcing. And event sourcing is a really attractive pattern that basically it records and store all the changes made to an application state, and it records the data in the same order in which the changes were were originally applied. That is the whole point of event sourcing, right? When we're talking about event sourcing, the main idea is that you have an application state and you also have an event store, as you can see in the diagram. And when you have event sourcing in play, the only test that you want to do is that if for some reason my application state gets wiped out, or I lose state of the current behavior, the current application state, right? If for some reason I lose that, I can still recreate the whole application state by just replaying all the events that I have stored in my event store. So that's all when it comes to event sourcing in terms of how it works, right? In terms of the concept itself. Well, the idea in event sourcing is that, again, right, we want to implement the system in such a way that we should be able to delete, right? That's what we should be able to do. We should be able to delete and wipe out the current states completely, and we should be able to recreate the same state with the stored events. Now, if we take the same example of the global scoring application, right? And let's assume, okay, let's assume a citizen has a really low score for some reason, right? And maybe we have a dashboard exposed with all the data that they can request. They can request their current score and all. And for some reason, they see that they have a really low score and they are requesting for an explanation of what actually happened, right? Well, with event sourcing, that would be fairly simple, right? Right? You can just replay all the events up to the current point, right? And you can then showcase the entire flow for that particular citizen. It might be that there will be years of data. There's another really nice feature in event sourcing where you can create snapshots, and you can just start from a particular snapshot, which is again a point in time up till the current point, and you can just showcase the whole event and show what actually got changed. It's not just a database that's a column that's holding your current score, right? It's basically the whole flow which you can replay and showcase that at 6th of December, this is what happened. At 12th of December, this is what happened, because you have all the events stored, right? And they are persisted, if you can say it that way. Now, there are tons of other examples that we could talk about and show how powerful event sourcing is. So let's assume the entire state gets wiped out for a reason, right? For our global application. And we lose all the scores and the states of all our citizens, right? We don't have access anymore. Since we have event sourcing in place, we are able to replay all the events where we could see that citizen X having an accident on a particular day, citizen Y committed a crime on another particular day. And with this approach, we can form our current state really easily, right? Because that's the idea. Another key feature of event sourcing is that we are able to time travel. And since we are able to time travel, it's also giving us the ability to debug, right? So if some issue occurred, or there was an unexplanatory thing that happened in your system, we can just time travel back to that particular event or to that point in time, and you can easily debug because you're having a 100% audit kind of system. When it comes to pros in event sourcing, I would say one of the major advantages that you are able to keep track of what happened in the past, because I think that's really important when we're building systems, and if that is something that is central to us. If you want to make sure what happened in the past, if you want to replay the event, you want to make sure that nothing that was missed out in our current flow or current state. Another great advantage of event sourcing is parallel processing. So if you want to introduce a new service, a new microservice, a new consumer, doesn't matter, right? We can do that. I mean, if you want to introduce a new microservice that holds the same state of another service, right? You can load all the events in that new service, and you can just play them so that the service gets up to sync. So that is also a nice feature of event sourcing, since you are storing those events. If I could talk about a con, there are some cons. One of the major con is what I see is that when you are replaying those events, there might be operations that require you to make additional API calls, for instance, right? Maybe you're manipulating a data somewhere else, or you're requesting data. So if you're replaying this event and it comes to that point where you are going to make that additional call to the third party, that would be a problem, right? Because we know that might cause data corruption at both sides if you are mutating data over someone else's application while just for replaying purpose, right? That's a con, but again, that is something that can be solved, right? There are two ways to solve that. One is that if you do need the response of the call you made in the past, you can store that, and you can use that as a mock response while replaying your events. And if you don't need the response, you can just simply mock the call, or you can just get rid of that piece of code that probably makes the call to the third party, right? So that's one way of solving that con. And I think eventual consistency might also be a problem in event sourcing if you are hooking up multiple services to an event queue, and you're trying to, some of the services might be out of sync when there's a lot of data being written, right? But again, this will be resolved over time when there are no more writes into the event log. So that's one of the con, which is not really considered to be a con. It depends on how you want your system to be built and whether or not you can afford that out of sync data. And again, you can also implement mechanisms to have, syncing of your data across your system. So that's top of that, right? So there are ways for overcoming those cons as well. Yeah, so that's event sourcing. Maybe I could give a brief, summary, because I know it's a lot. Event sourcing is more than what I just discussed. But with event sourcing, each state change corresponds to one or more events, right? That's event sourcing. Because of that, it is providing us 100% accurate audit logging. And that is probably the major advantage of event sourcing, right? The 100% audit logging is what you're getting from event sourcing. Because event sourcing maintains a complete history of each business object, right? Implementing temporal queries and reconstructing the historical state of an entity is pretty straightforward. Again, events, they are immutable. They are not going to change. Event store, same thing. So I think this is a pretty powerful, pattern. And so there are different kinds of examples as well where event sourcing can be used. One of a nice example that I've read in an article was about an online, gaming application. So I mean, I'm not sure if you guys have played Call of Duty or some, gaming like shooting games, where probably, it's a multiplayer game. It's online, and let's say someone tries to make a headshot, right, to another player. So what happens is that whenever this request goes to the server, which is considered to be a shot, right, the server will check whether it's a headshot or not. So what the server does, I mean, it takes time for the request to go from the client to the server, right? That's obvious. But the server will check, hey, this is what came in for a shot, and it was taken for a position, let's say 1 or 2, let's say position 1, okay? And at that time, the server will check, is player 2 on position 1? Maybe player 2 changed from position 1 to 2, which is not considered a headshot anymore, right? So, the server will return, no, it's not a headshot, but you know that it was a headshot because that's the time when you took the shot. So how event sourcing can solve that problem is that the system can probably, record all the movements for both the players with the time. So time will be a factor here. And whenever a shot comes in, they don't check the current position of the player 2. They just check in the event log whether there was a time where player 2 was at this position. And if that's true, then it returns true, and you get the headshot. So that's a nice example of how event sourcing can be applied, and it's being applied in multiplayer games as well. And yeah, I think that's it for event sourcing. Maybe we can move to the CTRS pattern. So this is like the last pattern in event-driven architecture. This pattern is used in combination with event sourcing, and it just means that you write the data in a way that is different from how you read the data. Now, in some scenarios where you have more writes or more reads, you want to separate this from each other so that you can scale them, independently, right? That's the basic idea of having this separated out. Now, to explain this a little bit more into details, with a use case could be if you have like, let's say a lot of reads going on, right? And maybe the writes to the data stores requires heavy computational kind of operations. Let's say when you're making a save or when you're making an update to a database, and this save and update requires probably a lot of third-party API calls, verifications, and whatnot, maybe internal arithmetic operations. That's heavy computation, right, for a read. So that's a good idea to implement CTRS because you can see the separation, right? It is probably needed. So that's when a client requests for the data, just a get query, the data goes from the read model. And when another client makes a call to, let's say a write, the data goes from the other write model. So that is how we separate the write and the reads from each other. Well, if I could talk about a pro of this pattern, is that the main benefit of CTRS that it's allowing you to separate the read from the write. And because of the separation, you get independently scalability opportunities. So that's one of the major pros of this system. And to give my personal take on CTRS is that I did not get a chance to personally implement CTRS on professional projects. However, I did it on academic and personal projects. But I know that it is advised not, to use it very carefully because of its complexity. And there should be a clear idea of why CTRS could help solve a particular problem. Otherwise, it might, it might add more complexity into your logic, and it could possibly make your problem even harder to solve. So I think that is something you should always consider before going for CTRS. If there is a clear scenarios, clear use case for CTRS is needed, then I think only go for it. I think that's it when it comes to those patterns. I have given some examples. If you guys have any other questions, feel free to unmute yourself or drop it in the chat box. I will hand it over to David. Thank you, guys.
Let's give it a second before you dive in, David, because I just want to give folks a chance to process. And that was awesome, Shiva. Thank you so much for the overview there. I guess before you dive in, David, I want to ask you, Shiva. So given what you just described, what would you say are kind of the key advantages and potential? You mentioned a few kind of potential drawbacks. Like, if you had to summarize, what would you say are kind of the key advantages of each architecture? And yeah, just at a high level, just to kind of recap.
So we know we have all those patterns as, I would say, tools, right, available for us. It's up to how would I say this? It's up to you to decide which pattern to implement, because each pattern serves for particular use cases, right? We cannot just go ahead and say, we'll just use event notifications just to do this. But there should be a clear idea, because if you're using event notifications and by the end of the day, you're still getting a lot of load on your producer, then probably you're doing something wrong, right? So there's not, one way to go with when it comes to event-driven architecture. There should be clear scenario. It should be really obvious for, hey, this is the scenario, and I think this pattern fits the best in, this scenario. So I think that's how I would describe when it comes to, choosing a certain kind of a pattern. But again, they all comes with their pros and cons. You have to decide whether you can afford those cons in order to make use of those advantages, which are the pros, right? So that's something you have to see based on your project basis, based on your needs and your requirements.
And pardon my ignorance, but is that something that within a single project you could use multiple of these, or is that just
No, yeah, that's a good question, actually, because it could be that you could have all the 4 patterns in your system. That's also something that happens. Yep.
Got it. Very, very cool. Good deal. So again, we got a question coming in. So in the event description, there was also a low state transfers as a use case. Did I miss that in the presentation?
Yeah.
Is that something you're going to be touching on, David?
Yeah, no, I think there was a typo there. It's actually event carried state transfer. Yes, sorry for that. I think it's on the meetup advertisement, right? Where we are advertising in the description. We have something called low state transfer and I think CSRT, but I think those are typos. Yeah.
Got it. And could you define what that is, just to further clarify that distinction?
Yeah, sure. So the question that was
what
asked,
you were just describing.
Yeah. So there was so there was also low state transfer as a use case. So David, if you could just go back to the third slide.
The third one?
Yeah, third one. Yeah, so this is it, the event carried state transfer. So whatever was written as low state transfer is actually, yes, right.
Perfect.
I hope that makes sense.
And then we got one more question here, or more of an insight. Probably also a downside of event carried state transfer for some domains is the missing workflow / process overview, as this is a choreography pattern.
Exactly.
Could you just maybe expand on that, either Shiva or Marcel, if you want to unmute and expand? I know that choreography pattern is something that we thought about including in this talk, but ultimately decided that there just wasn't enough time. So that's definitely, we'd love to do additional events covering these topics, and that's definitely one that I know there's interest in covering. So just to put that out there, but Shiva, could you maybe define
I think he was
choreography
pretty
pattern?
clear. Yeah, I think it was pretty clear how he mentioned, right? Because it could be one of, and it most probably is one of the downsides. And most of the times we have, to deal with those kind of things that, there are missing workflow processes, overview inside included, right? So I think that's pretty well defined there. Yeah.
For folks who
But
aren't familiar, what is the choreography pattern?
so what I want to add on this one is like totally depends on your design. So if by missing workflow slash process, that you mean if you mean there is some missing logic in an application, that's certainly a downside. But if you can design a system in such a way that it can be it cannot be it could not be any dependent on any domains, specific domains. It can be like a generic workflow that can match every domain, and then the consumers can decide what domain they can parse their messages into.
Got you. Anything else to add, Marcel, out of curiosity? No pressure.
And I think back to your question, Jacob, you mentioned what a choreography pattern is, right? It's just an idea of that we implement, a system where, let's say, microservices, they really don't talk to another service in order to, construct an action. That makes sense.
Cool.
It's basically like a choreographer or orchestrator, that's instructing each players to play their instrument and then creating a great music. So
Choreography.
that's
Got it. Sounds easy enough. Great. So David, you want to go ahead and kick off the second part of the conversation? Thank you, Marcel, for the insight. Thank you for the great question, Nan. And yeah, please keep chiming in because this is awesome. Thank you, everybody.
So hello, everyone. So please pardon my the example. It may not make much sense because I just created like 2 hours ago, but I just wanted to explain and get opinions on how we can use an event-driven architecture to scale an application, enterprise application, and then how we can make sure that we design our applications in such a way that we can scale it properly, and then we can test it individually without being dependent on each other, and then use the event-driven architecture along with that. So this example here just talks about API that, this whole API, this block that takes a request for creating a student. And what this API does is it gets all the previous school for the particular students. There's another API that talks to another service that gets all the old subject that the student has taken. And then there's a third API that gets the parents' detail for that student. So what in this monolith application, what's happening in this monolith application is like a request comes in, and then there's 3 processes happening side by side, not side by side, one after another. It's getting the previous schools, and then it's getting the old subjects, and it's getting the parent details. So it's waiting on all of these 3 requests to get processed before it sends a response back to the user. So this is totally a sync invocation. So there is no async process. So what I feel is one of the great advantages of having an event-driven architecture is like you can greatly reduce the processing time. You can simply say that you created a user, take a request from a user and say that I'll take care of it and I'll get back to you later. So that's an event, right? It will create an event, and then at the end, once the event is successfully consumed and processed, we'll get back to a user saying that we completed that process or that request that you just sent, right? So and then the scaling part, like even like how much. So if you try to scale this application, this whole monolith application, no matter how many instances of this application you create, it'll always get stuck on on these 3 events working together. So it will always have to wait. All of those instances, no matter of the request, will always have to wait on getting this information, and getting the last information. So yeah, it won't reduce your total time of calculation and solving the problems, but it may reduce some time, but not much. So on the next slide, we see how an async invocation could solve this problem, right? So let's say if you have a request and then you have a service that just deals with the request saying, hey, I received your request, I'll get back to you later, and then pushes event to our system that processes the event. So, and there are multiple listeners for this event. So each of these listeners could parallelly listen to the request and do its job, and then send final output to a storage. There is another listener that listens to a change on the request and responds to the incoming request. So what happens in this pattern is like so this is a separate entity which can be tested on its own. This is a separate entity which can be tested on its own, and then this one is the third entity which can be tested on its own. So they are not dependent on any other systems. Also, if you want to scale the application, you can simply figure out which application is giving you, or which part is giving you the least or the highest processing time, so that you can only scale that application in layers. And the thing that we need to be careful about is like when we're scaling this application, it's not affect the whole async logic or sync logic. So that's something that we need to take care about or think about for designing this pattern. Also, like comparing to this architecture, you could save resources if you could only scale like certain part of an application that listens to an event. So that's another pros of having segregation and separation of concern using event-driven architecture and breaking down monolith applications into smaller one. So yeah, so that was our last slide, and we are open to the questions. So if we can discuss more on this architecture. So Jacob, I'm giving back to you.
Great, thank you so much, David. While we're waiting for folks to chime in, could you just reiterate the second point that you just made there, David, about the other advantage that you saw? Will you just I missed kind of yeah. Mm-hmm.
The resources part, I guess. So while scaling this application, this one application is taking a lot of resources. So in a context, right? So but when you separate each applications and figure out like which one or which function is your bottleneck, you can only scale that part of the application, which will save your resources at that time. So that's the next example that I saw while I was implementing in this in our project. So
got it. That's cool. So for folks in the room, I guess I'm curious to know, first and foremost, just kind of who here has experience with event-driven architecture? Is your experience, have you drawn similar conclusions to what we're discussing here today? Are there other challenges that you've run into, other opportunities that you see? Dan, I'm also curious to hear from you with your awesome platform that you're building. Are you looking to address some of these challenges with that platform, or how are you thinking about that? Don't mean to put you on the spot, but I'm very curious to know.
Sure, I'm curious to ask David. I think with some of the architecture that you've highlighted at the end, synchronous versus asynchronous, and being able to scale when you when say processing time of a service is too high or too long. With anything that you've worked on so far, what have you seen as like challenges with that, just that event driven in like overall, like what's challenging overhead to like do, or to like retries or things like that? Like what have you found is difficult or takes time to figure out, right?
So based on my experience, the challenging thing in this whole event-driven architecture is to maintain state. So if your application totally depends on state, like let's say you need a synchronous way of dealing with things, right? So in that case, I would reconsider using this design and then try to see like any other solutions. So because this is totally asynchronous, so you won't know who is actually requesting the events or requesting the resources at the time when it gets processed, right? So yeah, the maintaining states of like different parts are a little bit challenging. As far as retries and reinvocations, I think that can be handled pretty easily.
And just curious, what platforms do you like to, or have you used? Is this all like custom stuff, or using like your own message queues? I'm just curious about the stack. I know I think the description mentions some stuff about AWS. I was just kind of curious what your tool, or things that you've used in the architecture.
Yes, so basically we have used AWS as well, and then we are slowly migrating towards GCP. So in AWS, if you are designing a serverless architecture, I would say events are very important, because if you are trying to communicate between your resources, like let's say Lambda or AWS S3 or PubSub or the SNS, SQS, or any of these applications, they emit events, right? And then those events could be consumed by any other resource. So let's say you upload a file into a S3 bucket, right, and an AWS, that will trigger an event, and that event could be processed by any virtual machines, that any application that is running on a virtual machine, or serverless compute function, or anywhere that if you want to push that into PubSub and listen from that PubSub, based on the demand. So yeah, so all of these queue events would be very important in AWS.
Cool. Thanks for context.
Did I answer your question correctly, or?
Yeah, I think so. You shared some of the pieces that you use and the the essential like events that you can use. So yeah, I think so. Thanks. I don't want to monopolize all the time.
No problem.
Is there a way to do this outside of the large cloud platforms, out of curiosity? Like a similar approach that doesn't require AWS or Google Cloud?
So Siva, you can answer that if you want. Or
Sure. Yes, there are multiple like tools that you could use in order to work with events, store events, emit events. I mean, work with Axon. There are a lot of tools. Axon is one of those examples that I've worked with to support those event-driven architectures. So yes, that is possible.
Cool. Dan, I would love to give you a chance just to share quickly what you're working on, given the highly relevant nature of your project.
Sure. Yeah. Well, I'll try to be brief. I can be long-winded at times. Yeah, I was so fascinated. Thank you both for what you're sharing. I'm trying to soak all this stuff up because I think that sometimes these event-driven architectures can be daunting for people that haven't done them or implemented them before, or thought about these patterns. Like, they're really complex, and honestly, like there's areas where both of you are like way beyond my understanding and technical. abilities there. But yeah, I think that in general, they're really fascinating to build, but I think that sometimes it's not very approachable to most engineers or smaller teams that don't necessarily have the resource or infrastructure chops to set up these systems and build them right, build them well and reliably. So yeah, what I'm working on right now is basically a system that encompasses all the different pieces of the architecture that you might need to go event driven, and you can implement it however you want. But really fundamentally, it's, an event happens and you execute some code. And what we have is we have an event stream unified that you don't need to configure or worry about or manage. Like, you don't need to set up your Kafka and know how to configure all that and make sure that it's working and reliable. Or any of these event streams and whatnot in AWS or Google Cloud. So what we have is, what we're building is trying to build something that makes it much more approachable and much easier. So you get all your messages and your history, and you can replay everything much more easily in a centralized place. So we hope that most of the engineers can spend a lot of time writing the code and building their applications for their customers instead of losing time to standing up a lot of infrastructure on AWS and connecting it just correctly and configuring. So that's what we're trying to do. Jacob shared the link to our site in the chat. We're called Ingest, and we are very new, and we are changing everything every week. So we are trying to soak up as much information or ideas or feedback from anyone that wants to. So if you're curious and it looks interesting to you and you want to give feedback, I would love that. So I'll just drop my email in here. So yeah, thanks for letting me plug it.
Absolutely. Please do drop your email. Perfect. And just another reminder that, a lot of information to process. So please, I dropped the link again for Collider Slack. That's an asynchronous channel where we keep the conversation going. So if you think of a question later, Shiva's in there. If I'm not mistaken, I think David's in there as well. So Dan's in there. We'll definitely keep the conversation going. So please do join us there. Marcel with a comment here. So he said, I used event sourcing with CTRS in the past and liked it very much. Event sourcing has such great possibilities business-wise and also architecture-wise. That's really awesome, Marcel. It's great to hear. Curious if you'd be willing to share. Again, don't want to put you in the spot, but any particular possibilities that you see that you find particularly intriguing, Marcel? Zero pressure there. Just really looking to understand from everybody who's working with the technology to hear different perspectives. So anybody else who has a perspective to share on that as well, just kind of opportunities and challenges that you see with the system. And I know you're chiming in from Germany, so I don't know, you might be cranking with the Google Translate right now, and take your time, no pressure at all. But that's really cool. Yeah, no worry at all. Take your time, Marcel. In the meantime, curious, yeah. Anybody else with any just kind of thoughts or questions to share? There's no wrong answers here at all. This is a very friendly group. Got a few more minutes, so please don't hesitate to chime in. While Marcel is typing, I want to just remind everybody that we've got an awesome program coming up next Tuesday. It's actually, fun fact, it's the same cloud transfer that Shiva or David, I forget who mentioned, was referencing. So several members of the Altimetric team, which is our parent company, are working on a project that's transferring from AWS to Google Cloud, if I'm not mistaken. So that's kind of the basis of that conversation next Tuesday. Another member of our team will be diving into the considerations and the process of what it looks like to migrate from one cloud platform to another, which sounds quite daunting from my standpoint. So I'm excited to hear how that process looks and hopefully make it a lot less daunting. Thank you so much, Marcel, for chiming back in. So Marcel mentioned in a short example, you can implement a new algorithm and test it with real occurred events from the past before releasing it and recognizing too late that the new algorithm is worse.
Exactly.
That's really interesting. Curious if anyone else has any thoughts on that to share.
Yeah, I think that's completely true. So I have a piece of code that just runs independently on based off an event, then you can just quickly test it out, try it out, scale it out, and figure out what the algorithm runtime is, how do the load test on it. So yeah, it's just better if you separate the concern in that way. I totally agree with Marcel.
Super cool. Great. Well, we are at the half hour here. So this is technically the end of our session, but again, the intention is certainly to keep the conversation going. Feel free to hang around for a few more minutes as we wrap up. And again, you can scroll up to the link for the Collider Slack to keep the conversation going in an ongoing asynchronous discussion. So we hope to see you there. Any final thoughts, Shiva or David? Thank you both so much for sharing your insights today. And yeah, looking forward to doing another session soon on either choreography pattern or something else related.